Hey everyone, welcome back to the channel. Today we are tackling a big one, Instagram. Have you ever wondered how a massive platform like Instagram handles billions of users, photos, videos, likes, and follows every day? Well, in this video we are going to break down how you can design Instagram in a system design interview. So, from the core requirements to high level and low-level designs, we will go over every key aspect to help you crush those interviews. So let's get started. So when you are in your system design interview, you have to follow specific framework. First is to gather the requirements and the estimation. And I would say that this is the most important step. And it's about like 60 to 70% of your succeeding of your process of succeeding in any system design interview. It's just to nail this first step. So first we need to get the functional requirement, non-functional requirement, and capacity estimation. And make sure that don't put a lot of functional requirement and non-functional requirement because you have only 45 minutes to establish and talk about your design and defend it and discuss it. So just make sure to make everything as easy as possible, as simple as possible, and also make sure to communicate with your interviewer all the time. So let's start with the functional requirement. In the functional requirement, we need to make able that our system have the ability to post photos and videos, follow and unfollow users, like or dislike posts. Maybe you can have like search photos and videos, and also to generate feeds. In the non-functional requirement, we need our application to be scalable. We need the latency should be pretty low latency. Our system should be available, durability and consistency and reliability. And I guess that in non-functional requirements, you find this way of saying like scalability, latency, availability. It's just going over and over most of all the time basically. Um, the next thing is to making some capacity estimation. So let's assume that we have 1 billion user and we have 500 million daily active user, assuming that we have a 60 million photos and 35 million videos. We can consider as well 3 megabytes as maximum for a photo and 150 megabytes for a video. And the user will send 20 requests. So if we want to make a capacity estimation, so photos will be 60 million photos per day, multiplied by 3, it will equals 180 terabytes. Videos, 35 million videos per day, multiplied by 150 megabytes, it will be 5,200 terabyte. So the total content size is 5,430 terabyte. The total space required for a year, it will be like 5,430 multiplied by 365, it will be this big number. Let's say that it will be 1981 or 1981 petabyte. Okay, we can talk about some bandwidth. So the incoming bandwidth will equals 502 because 5,430 terabytes. So let's say that the ratio of reads to write, it will be 100 to 1. So we will make sure that the application will be more to reads, not to writes, because we have like 100 to 1, and the required outgoing bandwidth should be, I guess, 50.28 TBS. Okay, so let's start to do design. Let's design our system right now. So we will have a client that could be like a mobile or desktop, like a mobile or desktop, and it will send the request through like a load balancer. And the load balancer, basically we're using a load balancer to distribute all the incoming requests across our web servers. And we will have we might have like Instagram web servers. Like we can have like multiple servers, like yeah, Instagram servers, and these servers will send the request to the services that needed. So we have a load balancer that will let's okay, let's do it better. If I put this one Instagram servers, and let's just do it like that. Oh, even smaller. And let's copy this and put it here. And let's say that this is server one. Okay, server one, server two, and server three. And server 4. Okay, it goes. Okay, it looks good. So the load balancer will distribute all the incoming requests across the servers. Let's assume that we have 4 servers, but it's not 4 servers. We might have more, but just to make everything simple for now. And the Instagram servers will send the request to the services. So each server has a services. So we will have multiple services, I guess. Here we might first have like a user feed service that will generate the feeds, um, and it will have like a user feeds database. DB. We also might have post service for the posts. And also it will have its own database because it's a microservice architecture, so each service has its own database. So post database, and please make it like that. And we might have as well let's say that we have media service, of course, to upload files and videos. The media service will have like media database. I guess it will be like an eth3 database or something, like a blob storage. Let me send this here. Okay. And we might have like pop. Let me think about something. Of course we should have a user service that handle the user information. No, just, and I guess it'll have like a relational database, like maybe Postgres or something like that. We can use it in this manner. We might as well have like also, but this one I don't want to overcomplicate everything, but we might use like Kafka to make sure that all these services have easy way to communicate with each other. But I will not put Kafka for now because I don't want to make everything quite complicated. So let's just let's leave it for now. So to understand the interaction within Instagram, we start with this use case Instagram diagram. It shows a key interactions like first the user will get posts, will see first will handle posts, will look at the feeds, and the media storage will do something like stuff like that. But let's just try to focus on each service by a time. First, we start with the user service. This service is responsible for user registration, authentication, and profile management. It handles features like user bio, profile picture, social interactions like follows and unfollows, and integrations with third-party social authentication provides like providers like Facebook and Google. Also, we will have like a notification service. It could be like a third party to make it easier for us to work on. The second thing, we have a post service. The post service The post service manages all aspects of updating, editing, and deleting photos and videos. It processes the upload media by resizing images, generate thumbnails, and transcoding videos for different devices resolutions. This ensures that content is optimized for display across variety of devices. We have the feed service, or either feed service. Let's call it feed service. We have a feed service. The feed service is one of the most critical components of Instagram. It generates personalized news feed for each user based on their followers, likes, and activity. This service uses distributed systems like Apache Kafka or RabbitMQ to handle real-time updates, ensuring that the feed is always fresh. Additionally, a caching layer like Redis, I guess, could help on that, and we will try to add more, but just this one, just like I would say that this is an easy a very high level design, and we got deep into it. The second thing, we have the storage service. Where is the storage service? I forgot to add the storage service, or we can add the media service. So yeah, it's a media service, or let's call it a storage service as well. Media files such as photos and videos are stored using scalable object solutions like AWS S3 or global or Google Cloud Storage. The storage service also implements redundancy as the disaster recovery mechanism to ensure that no data is lost, even in the event of hardware failures. I guess we should have as well a search service. I forgot to add it here. So yeah, search service, and it should like has like connection with like Elastic Beanstalk or something like that. Not Elastic Beanstalk, like Elasticsearch or something like that. Okay, so the search service enables users to find other users' posts, hashtags, and locations. It indexes relevant metadata and employs efficient indexes and search algorithms to deliver fast and accurate search results, enhancing the discovery of content. And we should have notification service. I guess this one could be like a third party. Like this service should be keeps users informed about activities that matter to them, such as likes, comments, mentions, and new followers. It push notifications to mobile devices using like Firebase Cloud Messaging or Amazon SNS, and leverages a queuing system to ensure asynchronous delivery of notifications without impacting performance. There is also comment service, and which is handles editing and deleting comments on posts. And there is also analytics service that track users engagement, post performance, and platform usage metrics such as views, likes, comments, and shares. Like this services gather data to provide insight that can be used to improve user experience and optimize content recommendations and support targeted advertising. So Instagram architecture includes key components such as like a client interface, content management, feed generation, and social graph. The system must be scalable, reliable, and secure. Users should be able to upload, view, and search images seamlessly. Components like feed generation use distributed processing to deliver real-time and personalized feeds to millions of users. I guess it would be a good idea for us to talk about maybe high level of like high level design for the scalability, like scaling and caching, because I guess this is not enough in your system design. Okay, this is a good starter, but this is not enough. First, we didn't talk about the database. Which type of database we'll use. We put a lot of services, and we talked about each service, and we need to talk about the database as well. But we need also as well to talk about scalability and caching. So to handle a scale of Instagram, caching is key. We use caching for frequently accessed data such as user profiles, feeds, and popular posts. This reduced latency and provides a better user experience, like lazy loading is another tactic, like loading content and stuff. Also, it's important to use like a CDN for the user to cache the frequently like to cache the images and stuff like that. It will help and improve the performance. Also, we can use cache like a Redis and distributed cache system. Like let's add like here Redis, which will be a distributed cache system, and it will be basically connected with our server here. To improve the scalability, and also we have our microservice architecture because we have multiple services. So Instagram is built on microservices that include user post, feed, search, notification, and analytics services. Each service is independently scalable and can be developed, deployed, and maintained separately. Using microservices architecture ensures that one server failing doesn't bring down the entire algorithm. Reliability is further achieved through a data replication and backup mechanism. And I guess it's a good idea to add, Kafka here, because we will need Kafka a lot, specifically since we are using a microservice architecture. Kafka, I guess the use for Kafka is needed, because I guess for example, the the feed service will connect with Kafka a lot, and also the user service. Where is the user service? The user service will send any new updates to Kafka. Also, the user feed, the feed service might take those updates to Kafka. Also, the post service, if we have any post service, it will be sent to Kafka, and the post service as well. When it try to update something, it will use the media service. It might connect it directly or connect with the media service with Kafka. Could Kafka handle all the communication between services, or we use it like accordingly if we need it or not need it? It depends on the specific requirements, and you can discuss that with your interviewer in your system design interview. So again, so let's talk about the real world consideration in the interview. It's also important to discuss real world factors like security and performance. Protecting user data is crucial, and Instagram employs access control, encryption, and privacy settings to ensure user safety. Also, it's pretty important to talk about this one. It's important to talk about what type of database we will use. In this one, I guess we can try to focus here on what is needed, but I highly recommend you to just think and look about the services. There is also notification service. There is also analytics service. I guess I highly recommend you to know if which type of database we are going to um uh on attempt to sorry, I forgot myself to attempt to add. So okay, in the low level design, I would say, okay, let's first start with the media service. Is blob storage a good one for it? I would say for myself, yeah, it's I guess you have to use like an blob storage like Amazon S3 or something like that. If we want to talk also on the user feed, we will use like a relational database, because yeah, it's we have like 500 million users, so yeah, we can add them in a relational database. We can use in the feed, we can use graph database to handle that. um Also, if we want to talk about the search one, we can use like an NoSQL database, like Elasticsearch or something like that. Like for the search, it will be like NoSQL database, like, or Elasticsearch database. It will be easier to search in it, and we're using like sharding and stuff. And yeah, it's basically comes to the consideration, but I guess this is the important discussion that you will go with your system, with your interviewer. Also, I would say something that in your system design interview, I might add too many services, but this too in the video because I wanted to cover as much things as possible. I guess in your system design interview, you will not have to add all of these services. You might have like more 2 or 3 services because all the requirements will not be that much. It might be we want something to just have the ability to update photos and that's it. And if that was a case, it will be like a 30 or 45 minutes interview. But if this all the function requirements, it's like a 2 hours interview or something like that that has a lot of details to talk in. But yeah, so don't just freak out when you see this amount of services. It's not yeah, it's not that scary, to be honest. So yeah, just take deep breath and yeah, and let's yeah, take a deep breath for it. We could also think on creating like database design for Instagram, like how the user will look like, how the follow user table will look like, how the upload table will look like. But I guess this could go beyond this video because I guess we did a lot of things and we did described tons of different things in this video. So yeah, if you like this video, make sure to subscribe and hit the notification bell so you never miss a video, and see you in the future.